Hey everybody, welcome to today's Kubernetes Masterclass, where we are going to go from Kubernetes 0 to hero. We see we got people rolling in right now, so we're just going to wait a couple seconds here to let some more people join. My name is Adrian Goins. I am not Shannon Williams. You probably see my name as Shannon Williams. Shannon normally hosts these things, but he's not available today, so he asked me to step in. I'm a senior solutions engineer here at Rancher. There's a bunch of contact information for me up there that isn't super relevant, but I am joined today from Spotinst. We have Amit Barros. Amit, are you with us?
Yes, hi everyone.
Hey, awesome. Thanks for joining, Amit. So Amit
Pleasure
is
to be
here from,
here.
yay. So Amit is here from Spotinst, and he has a fantastic introduction to Kubernetes and also to the unique services that Spotinst provides, which can help you in your Kubernetes deployments. But before we get started, there's some ground rules. So Rancher Masterclass series is a little bit different from what Rancher normally does around our meetups or around our weekly online trainings. This is narrower. So we really try to keep it to 40 to 45 minutes of presentation, leaving some time for questions at the end. And we encourage you to ask questions. If you look at the little GoToWebinar interface there, you'll see that there's a drop down for questions. Ask your questions there as you think of them, and we will pause maybe once during or certainly at the end and answer as many of those as we can. We do our best to respond to all questions, but please try to keep your questions on topic and specifically targeted for things that Amit is able to answer. This session is being recorded. Yes, I just checked. It is actually being recorded, which is awesome. So if you need to drop off for any reason, don't fret. This will be up possibly this afternoon, if not by tomorrow, on our YouTube channel. So you see the link down there, youtube.com/c/rancher. And there you can also see every other previous thing that we've done, whether it's a meetup or a webinar or a masterclass. There is a huge amount of content there for you to cover all sorts of things that are applicable to your Kubernetes journey. We also invite you to join the conversation on Slack. We have the Rancher users Slack. If you don't have an invitation for that, you can get one at slack.rancher.io. And then once you join the Rancher user Slack, join the channel Masterclass. And there you can chat amongst each other, or you can join it even after the class and talk to other people. That channel is persistent. So we have upcoming classes. Actually, I cannot hear myself anymore. Ami, can you still hear me?
Yes, I can.
Ah, perfect. Okay, it's just my headphones then. All right, so we have upcoming classes. We have on October 29th, we've got an introduction to Windows containers and networking with Rancher 2.3. Rancher 2.3 launched last week and introduces GA support for Windows containers. So if you're rocking Windows in your container environment, check that out. We also got classes coming up on Kubernetes the fun way. Hey, that sounds like a great thing because who doesn't want Kubernetes to be fun? And then data security strategies for Kubernetes. We have masterclasses pretty much every week. So check rancher.com/Kubernetes masterclass for upcoming classes and register. They're always filled with super valuable information. So with that, Amit, if you are ready, I will make you the presenter and you can take it away. You ready to go?
Yes, I am.
All right, just a second here. Oh yeah, it's this GoToWebinar thing where it shows me like every single person who is in the there you are. Amit Barros, organizer. Uh, all right, you should have the ability to take control and share your screen.
Can you see my screen now?
I see your screen and I see your first slide. Take it away, my friend.
Perfect. Thank you very much, Adrian. So hello, everybody. My name is Amit. I'm a solution architect from Spotinst. And today we're going to discuss a few different topics. In order to truly understand the story here, we will first go and understand cloud access capacity, which where Spotinst came from, and which is what we are basing all our technology on top. The next thing we're going to do is going to be a Kubernetes overview. We're going to discuss the barriers of managing a Kubernetes cluster. We'll talk a little bit about serverless containers, which is a growing field. And we'll finish by talking about Spotinst Ocean, which is our serverless container solution. And this will be the agenda for today. Of course, you're always welcome to ask questions, and we'll be more than happy to reply to them. So let's start by understanding cloud excess capacity. So cloud computing companies are building huge data centers, and that's in order to give you the feeling that you can consume unlimited resources. This causes a situation where a big portion of those resources are actually idle at all times. So in order to increase the usage, those cloud providers offer the same resources for around 80% less. But there is one catch. There is no guarantee for availability, which means those resources can be taken away from you by the cloud provider at any given moment with a very short notification. And that's where Spotinst comes and help you. We do help you manage your cloud excess capacity, and by that allowing you to reduce your costs dramatically and making your environment way more efficient. Now we're going to discuss Kubernetes. So Kubernetes in general is an open source system for automating deployment, scaling, and management of containerized applications. And if we'll break it down, it's an open source container management tool. It allows you to run containers at a scale, and it provides objects and APIs for building modern application, which usually will be stateless application or application that could shift and turn and change in a lot of ways. Kubernetes gives you a lot of value in that it adds portability, scalability of different applications, high availability. It's proven, it's battle tested. There are a lot of companies that are currently running Kubernetes in production, in dev environments, in all their environments, and actually at a very big scale. It's a market leader, and it's an open source tool, which means it has a lot of people looking at it and always adding more and more features and tools. So Kubernetes is built in a control plane and data plane architecture. We have two different components that are the main components of Kubernetes. One of them would be the square on the left, which is the Kubernetes master. And on the right, we have the Kubernetes minions or workers. Let's dive into those specific services that are running within each of those resources. So we'll start with the masters, with the control plane. The Kube API server generally deals with all the API communication through Kubernetes, or let's say differently, Kubernetes works based on API calls, which means all those different services that you see here, and the communication with the user or different applications are actually through API calls, and this handles the REST requests from Kubernetes components and users and actually makes sure it gets to the correct component. The second thing is the controllers. So actually a controller is a loop that watches the shared state of the cluster through the API server. It's constantly talk with the API server to see the state of the different things that are going to be running on top of the cluster, and it will make sure that it will reach the desired state. It will make the correct changes in order to reach the desired state that is defined by the user, and we will show that soon. The etcd generally a strongly consistent distributed key value store, or in other words, the database of the cluster. This is where the brain and all the information of the different components that are currently running on top of the cluster are being stored. The kube scheduler. The kube scheduler is actually responsible for placement of pods on top of nodes. This actually means that each pending pod or pending resources pod is actually, let's think about a container or more that is supposed to run. So the scheduler is the component that is responsible of running those resources, scheduling them on nodes. This is the control plane. And now let's talk about the data plane. So data plane is usually referred to as worker nodes, slaves, or minions. Depends which kind of Kubernetes you're going to install or how you're going to install it. The workers actually have two main services. The first one is the kubelet. Kubelet is actually the Kubernetes agent that is running on top of the nodes. This is the agent that controls the communication through the Kube API server and makes sure that all the configuration, that the controller are making sure that the pods are running in the correct state. This is the component that does that. And the second one would be the kube proxy, which actually helps distributing the network of the Kubernetes because we have another layer of networking, and the kube proxy is taking care of that. As I said, Kubernetes is built on objects. So generally, this is how the objects look like. You describe those in YAML or JSON languages. And based on that, Kubernetes will create your resources on top of the cluster. So the different Kubernetes objects, let's go through them. The first one would be namespaces. So namespaces is a logical group of pods, roles, config maps, and so on. Generally speaking, it's just an object that holds different objects underneath it. It helps you create different teams, different groups, different applications within the cluster. Everybody uses namespaces in different ways. The second thing would be the pod. Pod is the smallest deployable unit of computing. Generally speaking, pod will hold container or more. It would be one or more containers. The next thing would be labels. So in Kubernetes, everything is attached through key value pairs of labels. And actually, this creates the communication between different objects within Kubernetes. Volume is an abstraction layer for having persistent storage. So in case, for instance, that you're using AWS and you have AWS Cloud Controller, when you'll add a volume, it will create an EBS volume behind the scene that will be attached to your pods, your containers. Let's keep on going. The next object that we're going to discuss is a daemon set. So daemon set is an implementation, a single instance of a pod on a worker node. Actually, it means that if you have several different nodes on the cluster and you want to verify that each one of them will have a pod of a specific kind, you can use a daemon set. It's like a daemon that will run within your instances. It's commonly used for monitoring or logging. So generally, if you have a centralized monitoring or logging system, you can use daemon set to send them the information. The next object would be replica set. Generally, a replica set would hold one or more identical pods. It will always verify that you have the specified number of identical pods running underneath the replica set. And on top of replica sets, you can create deployments. So deployment actually handles declarative updates for pods and replica sets. And you can manage blue-green deployments using deployment. Actually, it runs and creates replica sets underneath. So you can create different versions of your application and actually shift between them in a very easy manner. And this is very useful. The next object would be service. Service is an abstraction way to expose an application running on a set of pods as a network service, which means actually a service exposes your application to the outside or within the cluster. So there are different types of services. It could be node port, it could be load balancer, it could be cluster IP. Some of them are external, some of them are internal, but this is the main idea. On top of that, Kubernetes implements DNS services. So you have core DNS. It's an open source DNS server that actually Kubernetes uses as the default DNS. And each service that you're running within the cluster and each pod is going to have a specific DNS to reach out to it from within the cluster. And if you expose it outside, you are able to reach it from outside as well. The next thing we're going to talk about is kubectl. So kubectl is a command line interface in order to interact with a Kubernetes cluster. You have a config file at your home directory at .kube. And generally, if you're using the correct context is the connection to the specific cluster, you can run commands on top of to your Kubernetes cluster and get the information that you want or apply new resources to it. We're going to see it soon through the demo. So the next thing we're going to discuss is the barriers of managing a Kubernetes cluster. So there are several different things we need to do when we manage a Kubernetes cluster. It requires a lot of work if we start from deploying the cluster itself, which is a pretty hard procedure if you don't do it with a managed service, through upgrading to the different components that are running within the cluster. Let's say a new version of Kubernetes just arrived. You have to install the cluster and you want to limit the downtime as much as possible. Usually, it's not a very easy or seamless process. You need to monitor the different components and make sure everything works fine with no problems. This is a hassle as well. It requires a lot of overhead from your specific company roadmap or goal. So you need to have a lot of expertise to do those things. And on top of that, you have the capacity management, that you always have to make sure that you have the correct capacity in order to run your different applications. So these are all things that constant work is required, and a lot of attention is required to make sure that everything is running smoothly. So we're going to start with talking about deploying and managing Kubernetes. We have technically two major different ways. We can do it in the unmanaged or the managed way. The unmanaged means actually that you deploy your own Kubernetes cluster from the masters to the nodes, and you are taking care of everything. So there are multiple ways to do that. You can use tools like KOps, like KubeSpray, and so on, Minikube, and there are many, many more. Or you can do it yourself, which means you're going to install all those components on top of instances and make sure they are running and communicating. And the different way to do that is the managed way. So with the managed way, you have different services of cloud providers like EKS, GKE, AKS, which are the three major cloud provider services. And you have tools like Rancher, which are hosting us, and it's very nice from them. And OpenShift and Pivotal container services, and there are many more managed services that actually take care of deploying your Kubernetes cluster, and usually gives you tools to upgrade those and monitor those and so on. I was asked to add that there are some polls that we added to this specific webinar, so it will be very nice if you guys could answer those polls in order for us to be able to understand your current situation. So this is about deploying Kubernetes. What I want to discuss now is the capacity management, and that's actually where Spotinst comes in hand, and you're going to see it soon. So let's assume a situation where I have two availability zones that are running within a Kubernetes cluster. I'm using two availability zones for a Kubernetes cluster. As of now, I have two worker nodes. Those worker nodes are currently empty, as you can see. The next thing that is going to happen, I'm going to launch new pods on top of the cluster. So these pods actually won't have any problems because the scheduler will recognize their requirements, their size, and their constraints, and so on, and then it will be able to schedule them on top of the nodes. Next thing that is going to happen, let's assume the cluster is totally full right now, and we're having a new pod coming to the cluster. What's going to happen now? The pod won't be able to be scheduled unless I'm going to remove another pod from the cluster, or if I'm going to add another worker node. But it actually required me to do an active thing and add a new node in order for the pod to be able to be scheduled. Next situation, I do have a place here to place new nodes, but this specific pod wants to run specifically on availability zone B. This is not possible, obviously, so it's going to wait up until I'm going to launch a new node in availability zone B. The next thing that is going to happen is I just fill this node, and now I get a new pod that has a PVC attached that is running, that it exists in availability zone 1A. I have an EBS volume running in availability zone 1A, and the pod wants to be scheduled. So technically, I would be able to schedule it here, but the volume is on the other side. So you probably had the poll pop up for you, so if you can answer it and come back to the slides, that would be great. So as I said, the worker node might have the pod running, but the EBS won't be able to be attached to it. So in order to really solve the situation, I will need to launch a new worker node in availability zone 1A. Next situation, I have a new pod. This pod specifically requires GPUs. What am I going to do now? The only way for me to solve that, even though I do have spare capacity, is to launch a worker node that has GPUs attached to it. Otherwise, the pod won't be able to use those. So I launched a new one, and now I have all the pods running. But there are a lot of unused resources, and you probably agree with me that this is pretty inefficient and a waste of resources. So Now, when we understand the scaling situation and we understand the capacity management and the work that is needed from this end, we can discuss serverless containers. So serverless containers in general, the concept is that you deploy a container on top of your cluster, which might be ECS for Fargate or Azure Container Instances or Google Cloud Run and so on. But the idea is that you deploy your container and the cloud provider will take care of your infrastructure. This is a very good concept because it takes a lot of the management from you. So if we look at the good things, it removes the need to operate and maintain the underlying infrastructure. It supports both stateless and stateful applications on top of containers. It's very dynamic, which means you can launch new resources and remove them based on scaling policies and so on. It's scalable. But the bad things about it is, first of all, the pricing. In cloud computing in general, whenever something is more managed, it usually costs more. The more the managed, the more the costs. It causes vendor locking because you have to use a proprietary solution for the cloud provider. You usually have no access to the underlying infrastructure. So I did contradict myself a little bit because I said from one end that it removes the need to operate and maintain the underlying infrastructure as a pro, but it's a con as well because sometimes you do want to debug and you cannot do it in this way. So allow me to introduce Spotinst Ocean. Spotinst Ocean is our serverless container solution. Actually, it allows you to run containers without managing the VMs on any cloud. So it's serverless in the way that you don't need to manage your VMs, but you're still able to reach out to them and log into them and debug whatever you need. It's an abstraction layer on top of VMs that's allowing you to deploy Kubernetes worker nodes without managing the underlying infrastructure. And let's understand what it means. So with Ocean, containers are first-class citizens. It means Ocean optimizes your VM sizes based on container requirements while constantly optimizing the cluster resources, both scaling up and down. But the main idea here is that Ocean allows you to manage your infrastructure from actually the deployment or the container's perspective. Why do I say that? Let's say you have a pod that cannot be replaced, that you don't want to run on excess capacity that can be taken away. So just mention that you want to run this specific pod on-demand, and we will make sure to run it on an on-demand instance. If you want this pod to have GPUs, you can just specify in the deployment level, and we will make sure to do that. Same goes for availability zones and so on. It's very simple to do, and I'll show it in a few moments. The Kubernetes serverless experience, this is Ocean. It allows you to run cheap, reliable Kubernetes cluster on the cloud at a very big scale. We use smart auto-scaling based on the pod requirements and constraints, taints, anti-affinity, affinity rules, taints and tolerations, and so on. We allow you to set headroom capacity, which means we will keep a little bit of extra capacity on top of your cluster based on your preferences. And by that, you will be able to rapid scale specific applications or deployments. We are aware of PVCs, which means that if we will have a PVC attached to a pod and the pod will have to be rescheduled, we will make sure to launch the instance in the correct availability zone to make sure your pod is attached to the EBS volume once again. And we add more and more features like the right sizing suggestions where we help you. We give you recommendations based on the actual utilization versus the request on how to specify your application requests. So if I'll go back to the example before, that was the state that we finished with. So what would happen with Ocean is that we'll actually make sure to scale down those instances in a graceful manner, and then the allocation of the resources would be as of this. And you will be able to actually maintain and save a lot of the cost by just reducing the cluster size. And on top of that, think about it that you're going to run on spot instances or cloud excess capacity, as I called it before, and reduce your cost dramatically. As for the right sizing, when using an autoscaler, it is very crucial to specify pod requirements. Because if you're going to undersize your pod, it might cause performance downgrade or over provisioning of pods. that could cause pod starvation or even affect cluster stability, really affect the instances themselves. And on the other hand, oversizing pods would cause idle resources in your cluster and a waste of money. So you want to find the sweet spot between those two to make sure that you have the best performance and the lowest cost possible within your cluster. What I'm going to do now is I'm going to run through a demo. I'm going to show you the system. I'll show you the environment that I'm running with. So the first thing, you can still see my screen, right?
Yes, we can still see your screen. Go ahead.
So here we have a running cluster with Rancher. This is a cluster that I created specifically for this webinar. And I have one running node. This node is actually all roles, which means this is my master. We'll be able to see it here as well. I have my Rancher server and my master of the Kubernetes cluster. I also have this Ocean cluster that I created before. So I'm going to reach to my Ocean cluster. As of now, Ocean doesn't have any workloads running on top of it, and we have one registered node to the cluster. So first question might be, how do we know this information? So if I'm going to go to my terminal, what you're going to be able to see here is that I'm going to run this specific command, get nodes, and I'm going to see that I have one node in the cluster. This is the node that we showed before. On top of that, I'm going to do get pods from kube system, and we're going to be able to see that I have a pod running inside of my cluster. This pod has a unique identifier that connects it to the Ocean cluster that you saw previously and sends all the metadata of the cluster to our SaaS platform. Based on that, we will make the smart decision of scaling up and down. So what I'm going to do now, as you've seen before, no nodes are running at the moment in the cluster, and the controller is attached. What I'm going to go do now is I'm going to apply this file, and after applying it, it will create 5 different deployments. So let's go into the file and understand what does it actually create. So this is going to be the first deployment that we are creating. Actually, this deployment name is on demand, and the reason it is called okay, just a second. I hope it's big enough now. Please let me know if you want me to increase the font a little bit more.
No, that's great. It's much more legible now. Thank you very much.
Sure thing. So the first deployment is called on demand. It is using Spotinst's proprietary node label, which is spotinst.io/node lifecycle on demand. If we run through this deployment, you're going to be able to see that we have those labels attached to the container, the app nginx, and we're going to have the nginx image. And our request is 700 milli-CPU and 700 megabytes of RAM and a quarter of a CPU. And the node selector asks for this specific deployment to run as on demand. The next deployment is called US West 2B. So same idea works here too. So Kubernetes has some built-in node labels. Some of them is the failure domain beta Kubernetes IO zone. And by using this node select label, I can specify the specific availability zone I want this pod to run in, this deployment, these pods. So this is this deployment. The next one is called test. And the reason it's called test is because it's running in a custom launch specification that I've created, a node selector label that I chose to use, which is environment and test. I'm going to show how it's being used soon. The next one is going to be no restrictions. That has a big amount of CPUs requests, but generally it doesn't require anything other than the request and limits. And the last one would be no launch spec, which I'm not expecting it to actually scale. I'm going to explain soon. But generally, it asks to run on nodes that has those nodes attached to it. And if I'm going to go back to Ocean, you're going to be seeing the following. I'm just refreshing the view. And we're going to see that I have 4 nodes that are being launched as of now. They are still launching. It will take about 2 minutes from now. and then we're going to be able to see new nodes in the cluster. Adrian, do we have any questions in the meanwhile?
We have a couple of questions. Yeah. Hey, sorry about the poll hijacking your screen. I totally didn't expect GoToWebinar to do that. I thought it was going to be more discreet.
It's okay, no worries.
We have a question from David, who is asking, how does Kubernetes handle spot instances that have been added or removed from the cluster?
So generally, the way we interact with Kubernetes to launch new instances is the instances are being registered through their user data scripts. So a new instance will be registered by that. And when we remove a node from the cluster, we're going to drain it, and then we're going to remove it actually from the cluster, only when we finish draining it. So it's actually we interacting with the cluster and making sure the instances are being registered and deregistered to the cluster.
Okay. We have some other questions, but nothing urgent to ask at the moment. I'd like to actually kick off that other poll if we have a minute to do that while the demo is going. Is now a good time?
Yeah, you can do that.
Okay. So as not to take over your demo again. This will be hopefully a little less lightning-like than the last poll. So let's see. Nice.
Okay, I see the responses are coming.
Yeah. About 50, 60%. We'll let it run for another few seconds here.
It's good. The instances are being already launched, so we're almost set with that.
All right. So we have another question that is asking if Spotinst allows you to have one Kubernetes cluster across multiple cloud providers. Does it have any functionality like that?
So the answer for that is, as of now, no. The main barrier for that would be communication, the networking. You need to figure out the solution to have a distributed network in order to make something like that to work. And as you probably know, within each cloud provider, you have different VPC, which is a different actual network. And this causes a lot of complexity in order to solve such an issue. But we would love to have a solution like that.
We have more questions rolling in. Do you have time to answer them now, or do you want me to save them for the end?
Let's save them for the end because I can continue now.
All right, perfect. So everybody keep asking questions, and we will have a final Q&A at the end.
Awesome. So as said before, new nodes launch to the cluster. What I want to show you is first we have different instance types within the cluster. We have instances running within different availability zones and within different life cycles. And if I'm going to go to the Rancher view, you're going to be able to see the different nodes that just registered to the cluster, and you're going to be able to see their labels. So as you can see, some are running as on-demand, some running as spot, and so on. And what I wanted to show you on top of that is the scaling activity that actually happens. So we're going to scroll all the way down, and we're going to look at this log. So specifically, I probably had an instance running in US East, US West 2B, so we couldn't be seeing that here. But what we can see here is that we got 3 different deployments and their restrictions and requests for constraints. And then we can see the instances that we launched based on that. We can see the pre-scale and post-scale CPU and memory. And technically, we can see another thing. As I mentioned, I ran a deployment called no launch spec. And the reason I did that is because I did not create a launch specification for this specific instances or pods. So if I'm going to go to the launch specification section, you're going to be able to see that I'm able to create new launch specifications and specify my own node labels. And actually, when we will recognize any pod that requires those node labels, we'll be able to launch new instances based on this configuration, where you can specify different security groups, different instance profile, images, different root volume size, And by that, you can create actually separated groups of nodes within your cluster if you need to. So this is another capability. As mentioned before, we support the built-in Kubernetes node labels. So you can use the host name, the zone, the region, the instance type, OS and architecture. You can use those as node selector constraints, or you can use it as affinity or anti-affinity rules. And on top of that, we have our own proprietary node labels, which are the lifecycle, and you can restrict scale down, which will tell our autoscaler to not scale down an instance while a specific pod is running on top of it. It will be as a label within the pod spec. And then generally, when we will recognize a node that can be scaled down, but there's a pod with that, we won't scale down this node unless there is a spot replacement or an instance replacement. And if I go back to my terminal, which I lost, here it is, and I'm going to do kubectl get pods, we're going to be able to see that all our pods are running despite the no launch spec that we cannot really launch the infrastructure for it. And this is the main magic of Ocean, because as you've seen, I did not do anything for the infrastructure other than specifying it in the deployment level. And based on that, we launched the correct capacity, and we will help you reach highly allocated cluster in this way. What I'm going to do now, I'm going to jump to another running cluster, and I'm going to overview the dashboards that we provide, because we do add some more features that I do want to show you. So the first, we'll see the cluster information, where you'll be able to see the amount of running instances. You'll be able to see the potential versus the actual costs. This is the on-demand price you would have paid. This is the excess capacity price that you actually paid. This is the amount of savings. Here you'll be able to see the allocation of the CPU and memory. For those of you that actually manage Kubernetes clusters, you probably are familiar with the fact that it's pretty hard to maintain highly allocated clusters, and we help with that dramatically. Here you can see the pod activity graph, where you can see the trends, and you can see new pods and what's running, what's pending, and so on. Node activity, where you can see scaling events, and you are able to see the distribution of different instance types and availability zones within the cluster. This specific cluster is running on one availability zone, but as you can see, we distribute, and the reason we do that is to actually achieve the highest allocated cluster as possible. And as this is a production cluster, the headroom that is being kept here is pretty high in order to always make sure that the capacity will be available for the pods to run as soon as possible. Two last things that I want to show you. First of all, of them is the cost feature, the showback feature actually. We show you a graph that actually gives you information about the costs of the cluster. Based on that, you can understand how much you're paying for each different deployment or namespace within your cluster. And by that, you can understand how much you're paying for each application that is running, and split your cost in a better manner, especially if you're a big company and you have a lot of different teams working underneath the same cluster. You can use that to understand the pricing. And the second thing I want to show is the right sizing feature. So as I said, it's giving you a recommendation based on your requests versus the actual utilization. So you have a cluster resources overview for CPU and memory. As you see, the difference is pretty high. And if we look at the top resizing recommendations, and let's say we're going to use the Meister API Meister. So I'm going to enter inside, and then we're going to see the following. We're going to see the deployment information, and we're going to be able to see the actual utilization versus the requests and the limits for both memory and CPU. And you're going to be able to see the recommendations. If we're going to take it a little bit longer, we're going to be able to see it through a week, and we're going to be able to see that the top we reached is around 5.5 vCPUs and around, let's say, 8 gigabytes of memory, sorry, 700 gigabytes of memory. And based on that, we give the recommendations to change your request on your application or service that you're running on top of Kubernetes. This is generally the demo. I want to summarize things. So serverless containers is a rising topic. Autoscaling and pod right sizing are crucial in order to run your applications on Kubernetes in a cost-effective way. Ocean is designed to allow you to focus on your application rather than the infrastructure. We want you to deal with the infrastructure the same that Rancher does for managing the Kubernetes cluster. We do for managing the nodes. And this is actually the connection. Those two services are complementary to each other. Use Rancher in order to deploy your application and monitor your cluster and so on. And you use Ocean in order to make sure you have the correct infrastructure for your needs and to allow you to actually focus on your application rather than the infrastructure. And to summarize everything, Ocean will help you run a cheap, reliable Kubernetes cluster on any cloud provider by choosing the right instance type, size, and lifecycle based on your application requirement. This is the main idea, and we really want the people, the programmers, to focus on their applications, not on the infrastructure, because the infrastructure is important, but it's kind of similar in a lot of ways, and it can be automated in this way. So I think we now have time for questions. I want to thank you all for listening as a beginning, and let's go for the question, Adrian.
All right, people are excited. We're getting a bunch of questions. So there are actually a number of questions. I'm also interested in this. We're getting questions about where there's overlap between Spotinst and Rancher. And from what I saw, from what you demonstrated, you're actually using a custom cluster where you're using the Docker run command to have new nodes join the Rancher cluster. But I'm wondering if you can talk a little bit about how you started this. How did you deploy the cluster first within Spotinst? Did you configure it within Spotinst and then add it to Rancher? Did you start with Rancher? And maybe as part of that, if you could talk about where the Kubernetes control plane fits into this, because we're also getting questions where people are concerned that, it's Spot instances. If you nuke the control plane, there goes your cluster.
Okay. So as for Rancher and Ocean, I first created a Kubernetes cluster within Rancher, and then I created the Ocean cluster, which is the complementary to this cluster. Generally, I just took the instance that was launched for me as the node for the master, etcd, and worker, and I imported all the configuration of it. I've added more availability zones and changed the user data script, and this is pretty much all I needed in order to make sure the nodes that Ocean will launch will register to the cluster. On top of that, I installed a pod inside the cluster, the controller, the Spotinst controller. And generally, altogether, this is the solution. As for control plane running on Spot instances, this is not the goal. This is not recommended. The masters should run on-demand. This is our recommendation. It is, of course, possible, but I won't recommend it. My master is running on-demand as of now. The first node that launched in the cluster, which is the master, is running as on-demand. And this is our recommendation as well. I hope that answers the question.
Yeah, that answered everything. Do they need to configure that on-demand instance independently, or can they still do that as part of the Spotinst configuration, but say this particular node is not to be run on Spot and is supposed to be only on demand?
So as said before, the instance was launched pre the launching of Ocean, which means I didn't touch the instance after the creation, which is the master. But it really depends on how you run your Kubernetes cluster. If you're using a managed service, it doesn't concern you at all. And if you're using KOps or anything like that, you can specify it within the commands of running and creating the cluster, whether you want your masters to run as Spot instances or on demand. This is some of the capabilities of KOps. As specifically for Rancher, where you do have access to your master, it's launching the master as on demand by default. Just keep it like that. You don't have to change anything.
There's a question about the Spotinst billing model, and I'll read you the question, and I don't totally understand it, but perhaps it'll make sense to you. The individual is asking, is the Spotinst billing model for Ocean the same as 10% of savings, or is it different?
So the answer for that is our model is based on, we take a certain percent out of the savings. It's not 10%. It's actually 20. And generally, we calculate the savings based on the on-demand price you would have paid versus the price that you actually paid for spots, and then we take percentage out of the savings that are being calculated. But if you don't save anything, you don't pay anything. So if I'm going to go back here to the overview, so this cluster would have cost $65,000. Actually, it cost $25,000. This is the save amounts, the subtraction of those two, and then we take a certain percentage out of this number.
Interesting. So these AWS instances are actually under your account, and then you're adding a small fee and billing the customer directly, correct?
No, the instances are running within the customer AWS account. We integrate within cross-account IAM role. You give us the permissions that we need in order to run the instances in your behalf. And then when you create the resources within Spotinst, we will launch the resources only based on your configuration, which means that if you choose to run only on-demand instances with our solution, you're not gonna pay a dime for that.
Oh, interesting. Okay. Let's see. Next question. So Himanshu says, since the cluster is running on Spot instances, how does it handle downtime? And he clarifies to say, I mean, how does it know if one of the worker nodes is no longer existing?
So generally, with excess capacity, it's not happening like this. The cloud provider gives you a notification when the instance is going to be taken away. On top of that, we learned in the last almost 5 years already, the trends of the spot markets, and we're able to actually try and predict that beforehand. And based on that, we will first drain the nodes and only then remove them if possible. But generally speaking, the recommendation is to always run more than one pod per deployment to make sure that you always have availability. The main idea of running containers is to move to cloud native applications that can be lifted and shifted and increased and add more pods to the same deployment. And by that, you can verify that you're always going to be running.
Okay. Does Spotinst have any integration with cloud-based load balancers, AWS type stuff, or is that outside of the scope of the services that you're providing?
I'm not sure I got the question. Can you repeat it?
Yeah, so your Spotinst is deploying worker nodes. Is there anything that you guys do with load balancers, elastic load balancers, application load balancers, any of the cloud-based load balancing?
So we can interact with those in order to import your workloads and register to those. So you can create our solution to integrate with a specific load balancer. So if we're going to go to Ocean specifically, let's say, because we're already there, I don't think I have any load balancers in my AWS account, but let's check. In the additional configuration, I'll be able to specify target groups or load balancers, which are here. And then every node that will register to the cluster will register to the load balancer as well. So you can do it within Ocean or within our product called Elastic Group, which is kind of similar to auto-scaling groups, but helps you utilize spot instances and allows you to fall back to on-demand and more features that we add on top of auto-scaling groups.
Awesome. Tomer is asking, how does a node created by Ocean that's running on AWS pull images that are in ECR when using EKS, the nodes automatically have policies that allow that?
So it's generally the same. You have to give the nodes the permissions to reach ECR, and then you can do that. It's within the instance profile attached to the nodes.
And so they configure that within the Spotinst platform, assigning those instance profiles?
Yeah, for each cluster that you are creating, generally you can attach an instance profile. So if I'm gonna go back here, I'm gonna be able to see here in the compute section, for example, that I have an instance profile. So I can give permissions based on that. So I can go to my IAM console and modify this specific role, or choose a different role to attach to the nodes.
Perfect. Jim is asking, what are the benefits for using Ocean over using just a managed serverless instance or serverless service on AWS?
So the main one there is cost, because the managed services like Fargate, for example, is pretty expensive, especially as opposed to running on top of spot instances, which you get major discounts for. So the main thing is discounts. The second thing is the added value that we had with our different services, like right sizing. Like we just added a new feature that is called workload migration, where you can just let us migrate your workloads from existing Kubernetes nodes to Ocean managed nodes. So we always evolve and add more and more features, and this is the main advantages. And of course, you have direct access to your underlying infrastructure, which is another good thing, in my opinion.
Is it possible to use a custom AMI for launching the worker nodes? That's a question from Santiago as well.
Definitely, you can do that as long as the AMI is consistent with Kubernetes and the AMI itself can register to the cluster.
That is it for questions. There are a couple of questions that I know some of you asked that are a little more specific to internal Spotinst policies, and I would encourage you to reach out directly to Spotinst and ask those questions, and they'll be able to work with you. There were also some questions that we didn't get to that weren't specific to the webinar either. So for those, the generic Kubernetes questions, if you guys want to join the Rancher user Slack, you can join the general channel or the Kubernetes channel, and you'll find people there from both Rancher and the community who will be more than happy to answer your questions. Oh, and
I've just added my email to the presentation. I think I'm still presenting.
Perfect.
So you are more than welcome to reach out and ask whatever question you have. I will be more than happy to assist.
There's one more question, which is kind of an opinion question. When you deploy Kubernetes, what operating system do you prefer to use? What flavor of Linux?
To be honest, it doesn't really matter. I mean,
do you have a personal preference?
I'm usually using the Amazon AMIs because I'm working on Amazon, but it really doesn't matter much. Ubuntu, CentOS, RHEL, everything will work perfectly fine. Every Linux distribution.
I'm an Ubuntu guy myself. But have you ever played with Gen 2?
No, I didn't have the chance to do that.
Oh man, Gen 2. I was big into Gen 2 for a long time because I really liked the hands-on functionality of it, and then I went completely to the opposite side of the spectrum and went with Ubuntu because it's so much more friendly.
Simple, yeah.
Okay, so that's it for questions. Is there anything else that you wanted to say or present before I wrap it up?
So I do see there's another question about, does Ocean use only spot instances? The answer for that is not necessarily. It really depends on what you configure on the deployment. And technically, I'm done. Thank you very much, Adrian, for your time and for allowing me to present here. It was my pleasure. And thanks, everyone, for joining.
All right. I will take back the screen from you and wrap it up. All right, so I don't actually have a closing slide. I just wanted to show again that we have upcoming classes. So if you enjoyed this, if you enjoy this kind of rapid discovery of technologies that'll help you in your Kubernetes journey, I encourage you to come back for more. I want to thank Amit from Spotinst for joining us today, and I want to thank all of you for taking this 55 minutes out of your day to spend it with us. We really appreciate your time. So with that, we'll go ahead and wrap it up, and I hope to see you all in the next webinar. Thanks for coming.
Thank you, everyone.